Now I am going to explain the important toolbars of the part design. So actually here none of the toolbars are visible. So sometimes it will happen, the toolbars may be missing. In that case we have to right click on any of these sidebars, this bar sidebar, anywhere you can click. Okay, here or here, anywhere you can click and press this down arrow. You can see this customize option. In toolbars, restore all content. Okay, restore position. So with that we can restore all the toolbars. Now the important toolbars are, first one is sketch based feature. Then second one is dress up feature. The third one is transformation feature. Then reference element. Then the sketch. So these five are the important toolbars. Okay, so now we will first see these sketch based features tools. So first one is pad. Okay, so to use these tools, first we need some 2D sketch. So to create that I am using this sketch tool. Then we have to select the reference plane. For example, I am drawing one circle. Okay, I am taking the center point, drawing circle. You know, you should use the proper dimension. You should turn this into green color before going to the workbench. So one circle I have drawn. Now if you use this pad tool, I can convert that circle into a cylinder of 1000 mm length. Okay, the solid cylinder I can create it. And we have additional options. So you can give thick. Okay, thick means instead of solid it will be like a tubular structure. For example, thick if I given, it is asking the second limit or this thickness and all. So here you can define the thickness. I am giving 2 mm thick. You can preview. Now you see, now it has become 2 mm. Either both side also you can increase. Outside also thickness you can give. So this is thickness. Then mirror extend. Mirror extend means opposite also it will be extended. Okay. And sometimes you can use the dimensions here. Even you can use, for example, some other components are there, means you can use up to last, up to plane, either also you can give. Okay. So using pad you can create solids. It can be a complete solid or it like a tubular structure. Anything you can create. So this is the first tool. Here also you can do controller set, like a admin software. Now we will see if we expand this part design. So this is normal pad, this is drafted filleted pad, this is multi-pad. Okay, this multi-pad I will explain now. For example, if you want to re-edit this sketch, select the sketch and select this sketch tool. Okay, it will go to the same sketch. Or sometime if you want to re-edit it, simply you can double click. This will also work. Okay, now I am drawing another one profile here. Okay, in rectangle. So you should give all the proper dimensions. So here 300, here 300, and we can make it a symmetry. Okay, now it is completely constrained. Now go to the pad part design. Now see, if I use this pad design, what type of 3D image I am getting. Select the image because both lines are in the same sketch. So actually in the tree you can see all the steps you have done. Okay, it is like a history. So there is only one sketch. Okay, there we have 2 profiles. So select that sketch. And you give say 1000 and preview. You see we got the material filled between these two profiles. Okay, here also you can give thickness. It will be like this. Okay, like tubular structure. It will extend on both sides. Okay, so if you use the normal pad option with the two profile, you will get the material filled between the two profile. Now assume okay, I will show how to use this multi-pad. Okay, this is a multi-pad. Now select the profile. Now we have the option where we can give separate the projection line for two profiles. For example, this is the first profile. I want to project this for 500 mm. Okay, see this rectangular is projected to 500 mm. Then second profile 1000 mm. Now if you view, you can see. So rectangle is up to 500 is projected, but the cylinder is projected up to 1000 mm. Like this type of image design you can create it. Okay. So next one is the last tool and the pad tool for drafted filleted pad. So first one is simply pad, but here we can do draft and fillet. So let me explain how to use this drafted filleted pad. Okay, I will modify this profile. Taking the rectangle. First use the normal pad. Just I need some base for that. Okay, I have base. So on this face, I want to create another one profile. For example, I am drawing another one square and give the k dimensions. Okay, 120. This here also 120. Then symmetry. So my profile is ready. Go to the part design. Now you know how pad will look. You simply select this. It will be projected to the 100 mm. For example, here it is 100. 100 mm it will be projected. Now we will see how to use the drafted filleted pad. Okay, select that tool and select the sketch. Now we are getting this type of window. So along with the length, it is asking second limit. Okay, for the second limit you can choose any plane or surface. For example, I am going to choose this surface as the second limit. Okay, so limit got selected. See, in addition to the pad option, there is option for draft and fillet. Okay, so now the default value they given is 5 degree. Now you give preview, you can see the edges are inclined to 5 degree. If it is not clear, you can further increase also. For example, I am giving 20 degree. You can see the edges and the side faces are inclined to the 20 degree now. And if you don't want to use this option, if you unselect it, it will be like a normal pad. Okay. Okay. So first one is draft, where you can define the draft angle 5 or 20. For example, I have given 20 here, so I am getting this type of profile. Then come to the fillet. So in the fillet, you know, fillet means converting the sharp corner into a rounded one. So already the default value is 5 they have defined, and 3 radius are mentioned: lateral, first, second. So second I have chosen this as the surface. So this is the second limit radius. Let's see how it changes. I am giving 20 for this radius. Just click anywhere so that this preview will be enabled. Now see, from 5 it is changed to 20. And then see first limit radius, it is again, so this is second, and the opposite side should be the first. Okay, so this 4 corner should be the first limit. That also I am changing from 5 to, for example, 30. Look outside, so this preview will be enabled. Now you see from 5 to 30 it changed. Then the last one is lateral. Lateral means, so these 4 corners. Okay, so these 4 corners, the edges, that also you will see. Instead of I am giving 50, click outside. Now so there is also changing. If you want further, you can increase, for example, 40. Okay, so like that, using the second option, we can pad the profile with fillet and draft. Okay. So next one is pocket. Okay, first one is pad. So pad is to create the material. Next one is pocket. Pocket is to remove the material. Okay, so just opposite. And here also, if you expand, you can see pocket, drafted, filleted pocket, multi-pocket. Almost same way it works in the pad tools, but instead of creating the material, it removes the material. Let's see. We can use the same rectangular profile. So we have a rectangular profile. So select this pocket tool. Select the profile. It is asking, so what is the depth to remove the material? For example, I am giving 20 mm. So for 20 mm, it reduces the material. Or you can give up to last. It will completely remove the material. Okay. If you know 100, you can directly give it dimension itself. Or you can use up to last. Or if some other plane is there, for example, okay, plane also in the end. If it is in the middle, if you want to create the hole from this face to the middle, you can select 50 or up to the plane, like that you can give it. So the pocket is just to remove the material. So here also thick option is there. So thickness I am giving just 10. You can see like a slot, it removes the material. Okay, if it is normal pocket, completely within this circular square profile, the material is removed. But if you select this thickness from that profile, 10 mm only it removes. Okay, if you give 20 mm, then from these 4 lines inward 20 mm it will be removed. Like that it is removing. Okay, so depth is defined here, and this thickness is defined here. Okay, and mirror extent both sides will remove, but here it won't be applicable because opposite there is no material, so mirror extent is not applicable. Okay, so this is how the pocket is working. The first one is pocket tool. Now you will go to this drafted filleted pocket. So I am selecting the profile. Here also same, it is asking me the second limit. For example, I am taking this surface as the second limit. If you give preview, okay, it is typing 100. That means throughout the thing it removed. Okay, I can reduce it to 50. So I remove it to 50, up to 50. So there is a draft angle 5 degree. If you want, you can change that to 20 degree. Press outside, then review. So in preview you can see from this profile 5 degree it is drafted outside. Okay, so it is similar to the drafted filleted pad. Okay, but here inward direction removes the material, that's it. And here also lateral first and second limit. We will start with the second limit, that is the first surface. Giving 20. You can see this curved edges in the outside. Then first limit, this bottom surface. There I am giving 40. You can see there also material removed for 40. Then this lateral, these 4 edges, okay, the side corners. There I am giving, for example, 30. Okay. So like that I can create the profile. The view you can change it. So this one is just shading. This is shading with edges. This is with edges without smooth edges. Like that, n number of options are there. Anything you can set it to view. See, shading with edges. You can see all those edges that it is created. Okay. Then the last tool, multi-pocket. Okay. So this is also same way as multi-pad. So So we needed two profiles. I have only one profile. So if you want to reedit this sketch, double click on the sketch. So there I can create another one profile. For example, circle I can take. Defining the radius is 200. Okay, now I have two profiles. You know, with these two profiles, if you use this normal pocket, it will remove the material between those two profiles. Okay, so if you use two profiles and use the normal pocket, it will remove the material between these two profiles. Instead, if you use this multi pocket, so for both profiles separately we can remove. For example, first profile, so after selecting this, it turns into blue color. So this rectangular profile, assume I want to remove the material up to 70 mm. Okay, on preview. Then this circular profile, I want to remove to up to 50 mm. So like this, we can remove the material for the multiple profile. So the next tool, shaft and groove. Okay, so shaft is like the pad. How pad creates the material, shaft also creates the material, but shaft creates the material with respect to axis. Similarly, groove, this is to remove the material similar to the pocket, but this groove also removes the material with respect to axis. So I have created one axis symmetric profile here. Okay, let's go to the sketcher. So normally I told you it should be the closed profile. Okay, if you want to go to the 3D model, it should be a closed profile. But this shaft and groove, it is exceptional. With the open profile itself, it can work. So now this is the complete profile. So I am going to rotate this profile about this vertical axis so that I can get like a jar-like structure. Okay. So without this line with the open profile also it will work. So let me show you. But it is better to close it. Okay. But I just wanted to show you. Without that also it will work. So I am trying this profile. So select the shaft, select this profile, then it is asking about which axis you want to rotate. For me, this axis, vertical axis, or in the tree if you see it is a Z axis. Okay, so here you can pick, or if it is not, I couldn't pick means here you can select the vertical axis. Okay, so it is, even though it shows the warning, it is an open profile, it will be created. Okay, that so only with this shaft and shaft we can create the 3D model with the open profile also, but it is better to be create the closed profile. Okay, so I have created the jar. You know, here also, so the shaft option also there is a thick option where you can define the thickness. So if you preview, you can see the thickness. But you can see where sir I couldn't see the thickness. Actually it will create like it is completely closed box, right? So from every profile it created the material up to 10 mm. So that if you want to see, so here you can check, you can see those lines are showing the edges of the solid model. So inside it is hollow, outside it is created. This is the one way of seeing. Or if you want to see another way is, go to the sketch, delete this profile so that it is not closed, now it is open. Now if you exit, you can see, okay, it is the like a normal jar with a thickness of 10 mm. Previously there is another line, so it is like a completely closed, but inside it is hollow only, it is like a shell only. I have removed it. Now we can see the thickness. Okay, the thickness of it you can see. So this is one option. Then second one is groove. Groove means you can remove the material. So better. So close the profile. And take this thick so that I am creating this solid profile. Okay, so using the shaft, assume I have created this solid profile. Now I want to remove the material about the axis, outside, inside, anywhere you can remove. So, okay, first we need the profile. So you can take any plane, go to the sketcher. Now you can draw the profile. For example, okay, you want to remove the material like this inside. So like this you want to remove the material inside. Now let's see, I have the profile, use the groove. So this is my profile. The vertical axis I want to remove. Got removed. So it is not visible, means this line should be coincide with this line, then that slot will be visible. Coincide. I can see the material is removed for the profile. Even outside also you can remove. For example, draw this, draw some profile, for example rectangular profile here. So for this you want to remove the material. Try group with this axis, material is removed. So like that you can create it. In the same shot using some other profile, simple profile, instead of chart you can take any plane. I am just taking this for rectangular profile. You know, if you rotate this rectangular profile about this axis, it will be like a cylinder, a cylindrical profile. So use shaft, then about this axis or line I want to rotate, and it will be like a cylinder. Now assume we want to remove the material from this cylinder. So go to the plane. Okay, so any vertical plane you can take it. So take the plane. Assume for this profile I want to remove the material above the axis. So you can use this groove. So select the profile, then select the axis. So the material is removed. Okay, so this is how the groove works. And the groove also we have the thickness option, that if you give. Okay, so with respect to the profile, for 10 mm it removed. Okay, you cannot see this inside cut. Actually there is a curved cut for 10 mm inside. Okay, like that you can see the thickness. If you don't define the thickness, completely it will be removed. That's it. So the next tool is rib and slot. So rib is to create the material, slot is to remove the material. So I will explain what is the difference between pad and rib. For example, pad just now shown. If you have a circle, you can project that into a straight cylindrical structure. For example, take one circle. So I have drawn one circle. So if you use the pad, I can project it into the straight cylindrical rod. Okay, but if you want to create a cylinder with a bent, then it is not possible with the rod design. Okay, it can be only a straight rod. If you want to create a rod with a bend, then that is not possible with this pad design. So for that purpose, we are going for this rib section. Okay, this rib tool. So for example, this is the profile, and so the bend profile I am drawing in the perpendicular plane. So the plane which is perpendicular to the profile I am taking. So there I am drawing the profile to create the bend. Okay, so for that I am using this plane to create the bend, and you can use any other tool also. For example, straight, then arc, another one straight. Like that, also you can try it. So always we have to create a fully constrained picture. So I have given these in the dimensions. Okay, so this is the bend profile. So now I have cross-sectional profile, also this top view profile, bend profile. Now you can use this rip tool. So this is the profile, cross-sectional profile, and this is the center curve. So for that it has created the cylindrical rod which is bent. Okay. Here also we have the thick profile, thick option, where you can define the thickness. Then it will be like a tube with a bend. So like that this rip tool is used. Then this slot also same way. So how pocket will work? If I draw one circle and it will remove the material just in this straight axis. Okay, but if you use this slot, again you can define that bend profile, center profile you can define it. Okay, so for example I am taking this face. Assume I want to create a rectangular hole in it. The cylindrical with thick profile itself you can use it. Okay, cylindrical tube if you want to create. Assume I want to create a rectangular slot within this tube. So I am drawing a rectangle, okay, square or rectangle. Then I need the profile, this bend profile. So if you remember those geometries, you can draw it again that profile. Otherwise, already we have that. So say as I mentioned earlier, in this tree you can get all the history, what are the steps you have done. So this 19 is the profile I have drawn. So simply copy this and exit. Now on this perpendicular plane I want to create it, go to the sketch, because I copied from the sketcher only. So again we have to go to the sketch and paste it. Now the profile is pasted here. Again you want to constrain it. Okay, so now I have the rectangular cross-sectional profile and this center curve to define the bend. So I want to remove the material. So in that case you can use this slot. Okay, if you want to create the material, you have to use rib. To remove the material, you have to use slot. So this is the profile, this is the center curve, the view. So now the material is removed. Okay, cylindrical tube with a square duct. Here also if you provide thick, then it will be like this. Okay, for that profile on both sides, 10 out the material will be removed. Okay, if you don't enable it, it will be like a normal tube-like structure. Next one is solid combine. So if you expand this solid combine, you will get two tools, stiffener and solid combine. So stiffener, you know that. So to support the member, we are using this stiffener. So first we need some structure to enable this stiffener. Okay, so I will draw the base component. Any plane you can take. So this is the plane. First I am taking a rectangular profile on it. That's it. add it to 20 mm. Run a small profile, so maybe 5 is sufficient. Okay, so rectangular slab. Now I'm going to draw one vertical member. I can pad it to 20 mm. Okay, so now bottom is my base. You can change the profile color, etc. Now you can right click, you can go to property, you can change the color if you want, you can give the transparency, everything you can fix. Okay, so the bottom red color is the base and this is my vertical structure. So I want to create the stiffness supporting material for this vertical structure. So the stiffener will be in this vertical plane, right? So I am taking that vertical plane. Okay, it's a little bit better. It's okay. So here I can draw the stiffener. Okay. Stiffener can be a straight line, or even if you want, you can draw some curved stiffener also. It's up to you. So any profile you can define for the stiffener. Now you see the stiffener is enabled. Okay, select the stiffener, or it is asking the profile. So this is my stiffener profile and thickness is 1 mm. Okay, for example give 3 mm. You can see. So for this profile, this tool creates the stiffener between vertical and the base. Okay, that's how we have to use the stiffener tool. The next one is solid combine. So solid combine is combining two different profiles, that is creating the solid profile from the two different 2D sketch. For example, this Y is a plane I am taking. Assume I am drawing one circle here. Okay, exit. Then now I am taking the opposite plane. Okay, there is a perpendicular plane to this circle. So in that plane I am drawing the rectangle. Now you see I have two profiles. Now I can use this solid profile. Okay, so this is my first component, this is my second component. Now if you preview, you see it created the profile, that is created the solid between these two profiles. Okay, using these two profiles. So this cross section is circle and this side the rectangle, it is taken as the length. Okay, even we will try some other structure also. For example, instead of this rectangle I am taking only up to certain thickness, not throughout the diameter. Now you will see how it comes. Use the solid combine, select two profile. Now you can see. Okay, we created the material between these two profiles. Okay. Then the last tool is multi-section solid, removed multi-section solid. Again, this is to create the material, this is to remove the material. So multi-section solid means, so the pad tool I told you, if you have the circle, we can create a straight circular cross-section cylinder. Okay, and the rip tool means we can create circular cross-sectional cylinder which has the bend. Okay, that we can create. And this multi-section solid means we can create the cylinder with a different cross-section. That is, initially it has circle, then it has the cross-section of rectangle, then square, like that. In this single cylinder itself, we can have the different cross-section. So let's present that. Okay, initially I am taking one rectangular, one circular profile, 100. Assume the total length of the duct is maybe 1000 mm. Okay, so 1000 mm cylindrical rod. One side I have a circular cross section, another side I have a square cross section. So second square cross section I have to draw it after 1000 mm. So for that purpose I am going to offset the plane. Okay, which plane? The same plane where the circle is drawn. Same plane I have to offset. For that you can use this reference element. Okay, this plane tool you can use it. So it is selected. So you see you can move it anywhere. Okay, and the length you can define it here. So I need the plane at 1000 mm. Okay, so this side it is created. So on this plane now I can draw the square profile. So take control and I can give symmetry. Okay, so now I have two profiles. One side circle, one side square. The total length is 1000 mm. So now we can use this multi-section solid. So we have to select first the profile, then the second profile, then preview. It shows. So there is a small issue. So if you want, you can use the coupling mode to ratio. You can give that. See what happened. There is a twisting happened. That's why it shows the error. Okay. So as it says in the coupling, you can give ratio. If you give, you can see the structure. Okay. Circle, this is rectangle. But again, there is a twisting issue. I don't want this twist and turn. So how to avoid that means, you should see the closing point. So for this circle, here is the closing point. Then for this rectangle, if you see, it is in the opposite side. So how it will create? It will create the that edges, closing edges from this closing point to that closing point. That is why it is twisted. So what I can do, this closing point I can shift it here so that both will be in the same side. So what I can do, I can right click this closing point, replace, then place it on this corner. No preview, you see there is no twisting. Okay, there is no twisting. So we have successfully converted. So we have created the cylindrical rod. One side has circular cross section, another side has the square cross section. Okay, so normally it will say you can change the coupling to ratio. Ratio will be solved. Okay, but still sometimes there may be the twisting error. So what you have to check is the closing point. Closing point should be in the same side, same point. Okay, if it is in, for example, if the closing point is somewhere here, what will happen? It will lead to cusp or some twisting will happen. So in that case, you have to check the closing point on both sides. You have to ensure the closing point is on the same side. Then you can create the thing properly. Okay, this is for the multi-section solid. Then removed multi-section solid is same way. It will remove the material from this. Okay, let's try that also. First I am taking this plane and it's going to fit all in. Okay. So here also, if you want to create a duct, that is tubular like structure, so for example I will try it differently. So this side I need this circular profile. Okay, assume this side I need the circular profile. So create the tube. So this side the cross section is circle. This side I want to create square. And use this normal view to change the direction of orientation, etc. Now also I have two profiles. Now we want to remove the material between these two profiles. Use this remove multi-section solid. One side circle, another side square. Review, again the same issue is coming. So even if you change this coupling to ratio, it will remove, but there will be a twisting. Okay, so what we have to do? We have to check whether the closing point is on the same side or not. Okay, here it is on the right hand side top. There we will check it. Okay. So let's see that. So there is no twisting. Okay. So sometimes with the coupling ratio itself, this will be resolved. Still, if it is not resolved, you should go for this closing point. Okay, so first option should be this coupling ratio. Most of the times software itself will show the notification showing the coupling to ratio. So if it is not solved, if it is twisted, then you have to check the closing point. Let's check. So next toolbar is dress up features. So sketch based feature is to create the solid model, then dress up features to do some operation on that created solid models. So you will see the tools. So before that I just created one square cube. You know how to create it. First one rectangle, one square profile. Then using pad you can convert that square profile into square cube. Okay. So you will see the first tool. This is H fillet. If we expand further, you can see 5 types in that. So first one is normal H fillet. Using that, I can convert the sharp corner into the rounded one. Okay, just let the round corner, sharp corner. So here I can define the radius 20 mm. Now you can see it's become round corner. Then second one is, so first one is normal H fillet, second one is variable radius fillet. The difference is, for example, I will select now this sharp corner. Okay, so 20 mm or 30 mm anything you can define. Additionally, here you can see these points. Okay, 2 elements. There if you select, then you can pick n number of points on this sharp corner, and you can double click on the value. So instead of 30 I can give 20 here. This value also locally I can change it. Instead of 30 I can give 40. Like that, n number of points you can give in between. Now you preview, you will get this type of variable radius fillet. Okay, first one is constant radius fillet. First tool is constant radius. Second one is variable radius fillet. Then third one, there is also fillet, but instead of defining the radius, here we are defining the caudal length. For example, this side if you select, the complete line it is taken. Okay, this line I am taking. This line I am taking. So caudal length. You can see instead of radius, it is taking this length. Okay, 40 mm. That I can change it to 50 or 60. So based on that caudal length, we are defining this corner. So first one is constant radius, second one is variable radius, third one is instead of radius, we are defining the caudal length. Then the next one, face fillet. To explain that better, I can make another one model here. Select this face. Then I'm just drawing another one profile. Again pad it to maybe 50 mm. Okay. Now this face fillet, I am selecting these two faces and preview you can see between these two faces there is a edge fillet. This also you can control 5, 20, etc. Okay, like that between the two faces it can be created. Then the last one is tri-tangent fillet, that is between the tri-tangent line as a face. For example, okay, this is what I am taking. So select the tri-tangent fillet. So faces to fillet. So these two faces. Okay, I have to create a fillet, and assume this face I have to remove it. Now if you preview, you can see. So these faces there is a fillet edge, and this side it is completely removed. Okay, so I will repeat it. Now I have sharp corner in these two faces. I have to convert these two sharp corners into a rounded one, and also I have to remove this face. So in that case you can go for the tri-tangent fillet. So these two faces I have to do the fillet. I don't want the sharp corner, and I have to remove this face. Then preview, you can get edge fillet with removed face on this side. Okay, this is about the fillets. Next you will see the chamfer. Okay, so using chamfer we can create the instead of sharp corner you can create the flat surface, flat corners. Delete it. Okay, so I am taking this as the base model. Assume I want to convert this sharp corner into a flat one. So you can select that chamfer. There you can choose which edges you want to change it. So default angle is 45. Simply you have to define the length of the face. For example, 10 mm I am giving. You can see the 10 mm distance. If you change to 20, like that. So this distance we can define. Okay, the default angle is 45 degree, and this distance also we can define. And also if you want, you can change it. Normally chamfer they will create it for 45 degree. So this is converting the sharp edge corner to the flatted one. Then the next one, draft, that is converting the straight wall to the inclined one. So first one is draft angle, then draft reflect line, then variable angle draft. Okay, so the same way. So first one is constant draft angle, the last one is variable draft angle. So we will see the first one. For example, this one is deleted. Chamfer and deleting it. So select the draft angle. So angle is 5 degree. Which face you have to draft? I am selecting this face. I have to draft, and neutral element. About which element you have to draft that. So select that. I am taking this upper surface. With respect to this upper surface, I want to convert this vertical surface into a inclined one. So degree 5. If you want, you can change that to 20. Review. Now you can see this flat vertical one is converted to the inclined one. Like this we can do the draft. The last one is variable draft. Same procedure. First you have to select faces to draft, then you have to select neutral element. Now you can see 2 points. Variable draft means select the point and you can create a number of points in between, and those intermediate points you can change the values. Now you see it is the variable draft. It is not the same angle, 20, 30, 30, 20 like that. So the third tool is, the middle tool is draft reflect line. So that is we can draft this face with respect to this edge fillet. Okay, select that. So we select this edge fillet and preview. You can see this line is drafted, which is tangent to this edge fillet. Okay, so this is constant draft angle, this is variable draft angle, this is draft created with respect to this H fillet. Then shell means converting solid body into a like a box-like structure. Let me show you shell. So I want to remove this face, okay, so that I can get the box-like structure. So if you want, you can select other faces as thickness, otherwise software will default consider other faces as the other thickness face. Okay, and thickness they are given 1 mm. If you want, you can change it. Now you can see the software removed this face and kept other faces with the thickness of 2 mm. Initially it was solid, now it is like a box-like structure. So it is a shell. The next one is thickness. For example, this face alone you want to increase the thickness. It is 1 mm. You can change it to 10 mm. So using this thickness, there alone locally you can increase the thickness. Then thread. Thread means actually here you can, if there is any cylindrical hole there, you can define what is the thread diameter, thread depth, etc. What will happen? It won't be reflected here. Now we have seen the material is removed, a solid is converted into a box-like structures. Those things we can see. But this thread or tab option, so it will be only visible in this. You can see there is a thread with a diameter pitch. The details will be visible only in the tree. It won't be visible in this product. Only in the manufacturer you can check it. That is thread. Then last one is so remove face. This is replace face. Almost the same only. So next one is remove face and replace face. So let me draw hole. So you can use this hole tool to make these circular holes. So I told you, market is to make the hole of any cross section. This hole tool is to create the hole of the circular cross section. So select the hole tool and select the flat surface. You can see the hole profile. You can define what is the diameter and what is the depth. Okay, and we can position it also because randomly it is created. We can position it using this positioning sketch option. So this white color point is the center point of the hole. For example, I can define the distance between this wall and the center point is 300, and this horizontal inches on this line is 300. Okay, now it is in green color. We have positioned it properly. Now okay. Okay, there is a blind hole. Okay, so it is a blind hole. Here you can change it. Okay, so if you want, you can view up to last. That means the material is completely removed up to the last. Assume I need a blind hole only. So give blind and the distances. We are 100 and we are. Okay, so one hole is created. Next one is remove face. So use the remove face. Assume I want to remove this internal face and I want to keep only this the outer surface. That means I don't want this whole itself. In that case, the pink color is the face to remove and this cyan color is the faces to keep. You will give OK. See the pink color face is removed and it is replaced by the surface. This is one way. We just doing control Z. So second code also almost same. Instead of remove, it is doing replace the same way. For example, so the outer one is the my replacing surface, and I want to remove this pink color internal surface. Okay, and remove. Okay. So remove face and replace face. It's the same way. So next one is the transformation features. So if we expand the first one, you can see translation, rotation, symmetry, axis to axis. So to explain that, simply I have taken one small cylindrical 3D rod, cylinder, circular cylinder. Okay. So now I want to translate this object, so use the translation. So which could be 1000 mm I want to translate, about which direction it is asking. So I can translate this with respect to any plane. For example, if you select this XY plane, you can see with respect to this plane 1000 mm it is translated. Okay, on both sides you can translate, or instead of XY plane you can select this ZX plane. In that case, along this plane above or below it can be translated. Okay, like that, depends on the direction of the plane we can translate the object to the required distance. So this is the first tool, translation. Okay, so next one is rotation. So I want to rotate this about each axis. So in the tree also you can choose it. This compass about Z axis. Okay, see, I want to rotate that with respect to the Z axis to the angle of 90 degree. You can see from here to here. Okay, so you can see if you rotate this compass also will be rotating. So this vertical axis is the Z axis, above the Z axis 90 degree it is rotated. And if you change some other plane, for example Y axis, so Y axis means above the Y axis 90 degree rotated, like that you can rotate it. Next one is symmetry. So I want to make a symmetry of this object with reference to this plane. So opposite it will be changed. Okay. So in the transformation features, so this one we have seen translation, rotation, symmetry. And this one is mirror. Then this one is creating the pattern. It can be a rectangular or circular or any random user defined pattern. Then this one, if you expand, this will be scale and affinity. So first protocol is over, the second one, the next one is mirror. The symmetry means this profile will be shifted to the opposite side, the same distance. Mirror means both original profile, modified profile, both will be there. Okay. So this object I want to mirror it with respect to this plane. Okay, so both original and duplicate model, both will be there in the mirror. But in this symmetry, the original itself will be moved from here to here. Okay, so this is mirror. And creating the pattern. So first you will see this rectangular pattern. So I want to create rectangular pattern using this profile. So create rectangular pattern. So how many instances I need? I need 5 instances. Okay, and with respect to this horizontal plane I have to create it. You can see now itself phi is created, and spacing between those will be, for example, 500 mm. Okay, so this is the object I have to create as a pattern, rectangular pattern. So I have to create 5 objects. Each should be spaced between spacing between these each component should be 500 mm. Along this plane I am creating it. Okay. And this is for the first direction. Similarly here you can see the second direction, where also you can define. For example, here also I have to create 5 instances and 500 mm gap between those. Okay. The direction you can change it here or there. You can change it. With that we can create a pattern of the same object. Okay. Equally spaced and objects you can see. This is the rectangular pattern. The same way we can create it as a circular pattern. For example, this object is a circular pattern. how many instances, for example 6 instances, and in between those products should be 60, and the reference element is this plane. The plane which is parallel to that. Now you can see a circle of 6 instances. For each 60-degree gap along this plane is created. Here also you can create curve. Okay, only one layer I have created. Okay, if you want, you can create how many circles you want. For example, 3 circles. Each should have 100 mm distance. Okay, the direction you can change it here or here. Circular pattern. The next one is user defined. Actually, in this rectangular and circular pattern, we get the option. What is the angle? Okay. What is inside, outside? What is the space in between those things? And all we got it. This is the we can user can define any type of pattern, not only rectangular or circle. For example, go back. Only one cylinder. Now go to the sketch. Okay, I am creating some series of points. Okay, assume these points are properly constrained. Okay, I have given proper dimensions. Like the assume. Now you will see these are all the points I have created. On that I have to create this same profile. So now first select the object you want to multiply this user defined pattern. Here you can select the points or positions. You can see on these positions the same object is created. Okay. So first one is predefined. It should be rectangle or circle. Last one is user defined. User can define any pattern, any shape. Okay. So next tool is scale. Okay, if you expand, you can see two tools. One is scaling, another one is affinity. So scaling means you can do the scaling in only one direction, along only one plane. Affinity means we can create the we can do the scaling in all 3 planes in directions. Okay, so this is the object I have to scale. Select the scaling tool. It is asking the reference. For example, I am selecting this plane as the reference, and 10 times I have to increase the ratio. Now you can see that the modified profile. Okay, this is 1 times the length. Now the length is increased to 10 times. Okay, so instead, if you select some other plane, for example, this y is a plane, see along this side, the 10 times it is increased. So only along one direction, you can change the scale if you use the scaling tool. So the next tool is affinity. So scaling will do increasing scale in only one direction or one plane. Okay, but this affinity will do scaling in all 3 directions. Same, this is the object I have to scale. So select the object, then go to the affinity. It is asking the origin point. Actually, we don't have any origin point, so you can create it. Simply right click. It is telling create the point. Okay, it is taking already one surface. Okay, but I will choose which surface, YZ or any XY plane, or any plane you can create. YZ plane or ZX plane. Okay, any plane you can create, you can take it. Assume I want to create the point at the center. Okay, so enter 0. Okay, now see the set point is created. Now you can do the scaling by giving the value in this x, y, z. So I am giving x is 10 times the ratio. You can see along the x axis. You can define. You can see this is the x direction, y direction is z direction. Okay, along x direction 10 times it is increased. Now along y direction, that is also 10 times it is increased. Then along z direction also 10 times. So completely the whole object is increased on all three directions. So this is how you have to use the affinity. So scaling will do scaling in only one direction. Affinity can do the scaling in all three directions. The center point alone you have to create it. Okay, we'll repeat it. First select the object, then affinity. You have to create the origin point. Create the point. By default, it is taking one face. That is this outer face it is taking. You can change it to any plane or anywhere you can create it. As I am creating on this ZX plane, I need this to be in the center. So define 0 here. So the point is in the center. You can simply define the values for x, y, z directions. That's it. 10 times it is increased. Then the last one, reference element. So you can create point or line wherever you want. You don't need to go to the sketcher. Here itself you can create it. So along this face you can see I can create a point. Okay, you can define the distance, etc. Similarly you can create a line. Okay, so between these 2 points it will create start point, maybe 100 mm. And to this it is created. Okay, you need 2 points. It can be a point or a plane. Between it can be created. You need to go to the sketch, or you can create planes. For example, you want to create another plane. So assume this plane I have to offset. So use this plane tool. You can see it is moving on both directions. Okay, so we can create planes also. Yeah, that's it. So sketch based features, reserve features, transformation features, reference element, finally the sketch. You know, by selecting that you can go to the sketcher module. There you can draw the 2D profile. Then exit to the part design again. You can convert that into 3D.